going to get started. I guess I should get the sign-in sheet passed around once I can find the notebook and whatnot. Okay, I'll go ahead and get this started with you. So we don't really have any lecture topics for today because today we're in exam review mode. So what I've done is I've already distributed out your homework 5. It has been graded. I'm going to pass out a homework solution here in a second. Real quick, is there anybody in here who did not get a hard copy of homework 6? I've got an extra one, which means somebody in here didn't get it. Just let me know if you need a hard copy of homework 6. I've got that due right now on the 29th of March, which depending upon where we get when we come back from spring break, I might have to push that back a little bit. It is what it is. But yeah, when we come back from spring break, we're going to go after columns like crazy. Try and knock that out and then spend the rest of the semester talking about beams. So that's sort of the plan. So today, exam review, we're talking about bolts and welds, and that's going to be what's on exam 2. So let me take a little bit of time and discuss the homework 5 solution, which it was one problem. There's really not a lot to say. The only thing that I guess is worth mentioning is, you have a 1/4-inch plate. So if you look at your minimum and maximum weld size, your minimum weld size is actually 3/16, or your minimum and maximum weld size. You don't get to use 5/16. I mean, you'd like to, but the geometry doesn't allow it. You end up going with a maximum weld size of 3/16. Now, when you go through and do all the weld balancing and all of that, you end up finding that essentially here's your weld design. What I was essentially looking for was that you got these numbers, 3.88 and 10.49. I rounded this up to 4, and I rounded this to 10.5. I think it's pretty easy to specify in the 1/2 inch. I wouldn't specify a weld that's 3/4 of an inch long or something like that. Anything that's an inch or 1/2 inch, I think is pretty reasonable. But all in all, there's really not a lot to say. Everybody did pretty well on it, so it is what it is. So let me go ahead and pass out a copy of that solution. Let me get the lights adjusted. And then I'll pass this out as well. Okay, so here's that. Here's this. I should go from this end, right? 1, 2, 3, 4, 5, 6, 7. I feel like I'm going to have less questions today. What? I don't know what you're talking about. Okay, let me pass out the exam 2 review so everybody has it. I actually think this is a pretty nice, concise little, hey, here it is on everything associated with the exam. What's up? I did not. With the solution or that. I didn't get one for the solution either. All right. So let's get into the review for the exam, and then we'll, of course, I'll entertain any questions. So it's open manual and closed notes. It's the same deal as last time. Same deal as just about any exam I've ever offered. So I think you all know the drill by now. You can put whatever you want on the formula sheet except for worked out examples. You know the deal. Try and be on time. We're going to do what we did last time, which is start the exam at 8:30 if everybody's all right with that. However, I think it's going to be, this one's going to be less of a time crunch as compared to a previous exam. This is going to be a little easier on the clock, but we'll still do the same deal. We'll start at 8:30. You all know the drill. I'll have scratch paper, I'll have stapler. Just bring a pencil, bring the manual, bring your formula sheet, and be ready to go. Here's the topic. Bolted connections. Make sure you understand the fundamentals of installation, of bolt behavior. Make sure you can analyze and design the following: bearing type connections, slip critical connections, and connections that are subjected to combined loading, and specifically shear and tension. Welded connections. Make sure you understand the fundamentals of welding methods and weld behavior, and make sure you can analyze and design fillet welds, including balancing a weld with an angle. And here's the long and short of it on formulas. So bolt shear and bolt slip capacity, you can look that up. Of course, you also have your FNT and FNV values and all that jazz in Chapter J, Chapter J. Your bolt bearing capacity is the only one that you really have to go through and compute, and the hardest one to deal with is your L sub C. So you have L sub C for the interior bolts, L sub C for the edge bolts, and remember, for bolts, you're not adding 1/8 of an inch, you're adding a 1/16 of an inch. Let's see, for combined loading, your nominal capacity of a bolt is FNT prime times A sub B, your area, your unthreaded area of your bolt. The FNT prime is a modified tensile stress, which you compute as the minimum of the following two quantities, and FRV is just your applied shear stress. So you can either do the shear load per bolt divided by the area of a bolt, or the total shear divided by the total area of all the bolts. Just make sure that you are consistent. For bolt spacing, your minimum bolt spacing is 2 2/3 times the bolt diameter, but the preferred spacing is 3 times the bolt diameter. S max is the minimum of 14 times the thickness, or 7 inches. And remember, there's actually 2 S max limits, but we're using this one because it's the more conservative. It assumes unpainted steel. Let's see, bolt edge distance requirements, the minimum ones you look up. The maximum ones are either 12 times the thickness or 6 inches, and that one doesn't change. That one is what it is. For welds, your weld metal capacity is the nominal, for phi is 0.75, and it's your effective stress, which is 0.6 times your weld electrode strength, times your area, which is the weld length, times your effective throat, which is 0.707 times the weld length, and that's just a trig. Base metal capacity of shear yielding and shear fracture, pretty straightforward. Notice that for fillet welds, your gross area in shear and your net area in shear are equal. So that one's pretty simple. Phi value changes this. Make sure you're accounting for that. Your weld limits, the minimum weld sizes, you look them up. Maximum weld sizes, it's either the thickness or the thickness minus a 1/16 of an inch, dependent upon where you are with your plate thickness. Greater than or equal to 1/4 of an inch. That's where the weld limit from the spec came from on that homework problem. So that was the weld limit that you used. That's all I got on review. You all have the homework solution. You've got the exam review. The floor is yours. 4 and 5. Yep. Did anybody not get the handouts? Did you not get the handouts, or did you not get handouts? Now, see, this is me. This is me doing this. Now, it's daylight savings time, so I give you a break. Yes. No, they're not actually. That's a good point. I would say that from a tabbing standpoint, this is what I would do from a tabbing standpoint. So number one, I would definitely have a tab right here on one of these. These are right next to each other. The bolt shear capacities, they're right there. I would definitely have a tab there. But if you recall, we were a little light on tabbing the bolt and weld sections of the manual because there's so many different tables that we're referring to that are all in the same location. So if you go to chapter J of the spec, now again, we had this discussion last time. Do y'all know when I say chapter J of the spec, y'all know what I mean? I'm talking about that back matter of the manual, not the section with the gray lining, and I'm going to chapter J. Okay, J.3 is the section, or J3, I guess, there's no point. J3 is the section that's related to bolts. J2 is the section that's related to welds. My advice would be to have a tab somewhere in those sections, but I wouldn't tab every single page because then it gets a little redundant. But I will say there are tables on just about every page that you'll want to use, like like if I skip ahead. So for instance, let's see, so right here, so bolt spacing requirements, table J3.4, that's where you get your minimum edge distance on 16.1-123. And then you've got your minimum weld sizes on table J2.4. So if you want to tab those, maybe that might be the most advantageous. But I would just have a tab somewhere in J2 and somewhere in J3. So that's a good question, though. Did that answer your question? Yeah. Okay. All right. Floor is yours again. Less questions than I expected. Okay. That was easy. I need the Staples button.
Just curious, conceptual question. I mean, this
Okay.
area. Like, what are you going to ask? Is this stuff that would be on these handouts, possibly? Yeah.
And what we talked about.
I'm going to ask you stuff. That's about we'll talk about. All right. Can we just move this to after?
Nope. Well, I tell you what. We could move it after break, and we could do the steel and the concrete exam on the same day.
Yeah, let's do a take-home.
What's a take-home exam? I don't.
Take-home celebration.
I mean, this is where the party's here. This is where the party's at.
It's not a party, unless it's beer involved.
It's something better. There's knowledge, learning. Learning is where it's at. So no, we are doing this on Wednesday. Anybody? No. Anybody? All seem tired. Yes, sir. What? What? I don't. What are you asking? I don't understand.
Just like an angle. I think a WT would like be a double angle. A WT just be even because
It's all symmetric. Are you asking about weld balancing?
Yeah.
Well, I mean, if let's say it was a double angle, or let's say it's a WT, or let's say it was a channel. If I'm welding the long side, it's symmetric in all of those cases, so there's no balancing. It's all about whether or not the centroid is off-center. So in general, you need to be able to handle a connection scenario where the weld is off-center. An angle is arguably the simplest example of that. Well, yeah, but you also need to keep in mind what's realistic. I mean, like I'm not going to throw a ridiculous, look, this isn't statics where I'm going to make you start computing centroids. That's not the point. So I'm not going to say, here's a weld and the cross-section has triangles and circles and elliptical holes in it and find the centroid. Like that's not what I'm doing. What? Yes. In the design, well, I'll say this. In design scenarios, I would prefer that you use S preferred because you know that's going to meet the spec. When you're evaluating whether or not a connection meets the requirements, you're checking against S min. Okay? The spec states that the minimum spacing is 2 2/3 times bolt diameter. So if I give you a connection and you're analyzing it, and I ask you to check its requirements, there is a possibility that the bolt spacing could pass 2 2/3 but fail 3. Fail 3 times the bolt diameter. That does not mean that the connection doesn't meet requirements. It does. Okay, but in bolt layout land, I would lay out according to preferred. But I will do my best also to remove any ambiguities associated with that on the exam as well. What? Okay. I don't understand. Oh. Oh.
That was just a good question.
Yes, it was.
You only say it's a good question because you got it right. You just got it. You be firing this man up if you got it wrong. But I did. Because I caught to the game.
But if I had worded it more clearly, I would have told you how to do it. That's why I will admit it is a tough question to word, but it would have been much easier if I just told you how to do it, but then it wouldn't be a celebration. Yeah, it would be for you. It would be a free throw.
I was in a free throw competition and I wasted my first 4 because I didn't know what was actually happening. Because the ref didn't blow his whistle.
So you thought they were practice throws?
Yep. So
Oh.
I beat 1 of the first 4.
Oh, wow. That's not, they should have, you think there'd be a big whistle or a, if there's a crowd, like they would suddenly start cheering when, when it gets started, They need remember when it started to get late on Who Wants to Be a Millionaire? And remember, like when they got really high up on the ladder, there'd be that, and all the lights would turn off and it would shine. Then you'd know it was starting. That has nothing to do with bolts and welds, not a thing. All right, anything else at all?
I'm trying to think of something that I'm
Man, you all are usually pretty good at all these questions, but you're slipping. This stuff's critical, man. I'm just saying. Yes. Still got it. But this is your free. You can ask. What my job here today is, I want you to be more relaxed about the exam. I want you to make sure that you're clear on everything that I can clarify. Good ones. I'll say this. I've given you, and I'll get to your question. I've given a fair amount of guidance in the past as to what kinds of conceptual questions I ask. What I will say is this. I'm a little aloof when it comes to bolted connections because I think as you're learning, there's not as much material. I'm going to be a little aloof on that. I'm going to play that pretty close to the chest. All I'll say is if you study the notes and you were there and recalling what we were talking about, you're going to be fine. So I can't really say much more than that. Yes, sir. Yes. Yeah. There's a fair amount of irony in that question, sir.
Oh
I mean, no, but you get the irony of the question, right? Are we starting the exam early? And then the next thing is, I was late coming in. What's that? Wait, what? You're like, that one didn't work. I will take a pass on that.
So typically we're going to use a max unless we do
Yeah. Because that's the largest weld that you can feasibly deposit in a single pass. As soon as your welds get larger and larger, you're having to run the electrode or the MIG welder, the stick, over it again and again and again. Which, let's be clear, if you're talking about a column base plate on a 30-story building, yeah, you probably going to have to, you know, and nothing you can get around that. But for a typical, you know, beam-to-beam connection on a floor system, you shouldn't have to do that. So. I just needed that said and vocalized. He goes, I'll speak into the mic if necessary. And I know some of you are like, I don't really have any more questions, but we have to be here for another hour because we've got concrete. Nah, I don't know about all that. We're behind in there. We're trucking along in concrete. Because there's people who aren't here. I do not know how we got behind, but we are a little behind in there. I mean, we're not like deleteriously behind, but I would like to sort of. It means, it basically is a big word for like bad. Deleterious is like a deleterious effect. Deleterious. Search deleterious. You like that word? It's basically bad, yeah. It's a big word for bad. Bless. Anything I can do to make the exam a little more relaxing. I can't really do much. And donuts. Donuts. But this isn't the final exam. Tell you what I might do, in all seriousness, what I might do is I really might bring donuts to the final exam because we'll see. Well, see, what I'm thinking is probably for the final. Has anybody ever been to Peace, Love, and Little Donuts? Okay, yeah, I'm thinking of maybe doing that for the final. You all got me this big cake, so I figured I can reciprocate that. So I'll do that for the final. How's that? On me. I'll get some donuts. Well, I'm also giving you an exam, so. What's this?
He's like, Dr. Chen, he has candy bars. He's like, you take, take, take.
Yeah, I've never heard him say that.
I do know when I'm using one of those markers because it's flat. I'm answering y'all's questions, and we're getting into donuts and things. What's that? That's up to you all. I mean, the thing is, it's 9:26, so if we if we say we're through, then some of you all will benefit, and then the rest of you all you have to hang out for another 35 minutes. What's that? Yeah, that's my point. I'm like, you're still going to be here, so. Hey, this is your time. So if you all decide that you're done and you want to just relax for a little bit and work on hydraulics or transportation or something. I really don't have a problem with it. But if we're going to do that, if we're going to call the session a little early, I do want to do that one last official. Any other questions? Last call. Are you good? You good? You good? You good? You good? These two over here? You what? Eat. Okay, hold on. No, go. The thinnest one, yes, because we're talking about heat. So, what's it going to burn through first? Yep. Exactly right. Well, first, hold on. You two got any questions? Well, I mean, do you, okay. Are you good, Mr. Gomes? All right. Then I declare this exam review concluded. I'm going to stop the recording, and some of you all, I guess, will bounce, and the rest I'll see you all in half an hour.